Alright gang, here we go. This is Chem 2 Unit 3. We're going to talk about the mole. We're going to do some basic mole calculations. Should be pretty easy. A lot of this should definitely be reviewed from Chem 1. So we're going to go through it pretty quickly. If you need additional practice, I've got loads and loads of practice you can do. So just let me know if you need some extra help with this stuff. But it is vitally important that you can do this stuff on your own. Otherwise, the rest of the year is going to be really painful, if not impossible. Alright? So Avogadro's number, so the whole reason we have the mole in Avogadro's number is because atoms and molecules are ridiculously small, and we can't just use a pair of tweezers and just pick out one atom or molecule and just work with that one thing, okay? So what it allows us to do by using a mole is to be able to count how many of something we have by using the weight of it. Okay, because each element is identical to other copies of that same element, right? And so when we have millions and millions of them, we can just use their average masses in order to figure out how many total ones we have, right? And so we use this thing called the mole, okay, and it's abbreviated MOL, and it's the amount of particles that are found in exactly 12 grams of carbon-12. Okay, that's how we define a mole, all right? So, for example, like this would be one molecule of water. We'll never have just one molecule of water. But if we have 1 mole of water, it weighs 18 grams. Okay, and so in 1 mole, we always have the same number of atoms or molecules. And it's Avogadro's number, and it's this guy here, 6.02 times 10 to the 23rd. All right, you need to memorize this number here, 6.02 times 10 to the 23rd. And this is where, that part is where we get the name Mole Day, right? On October 23rd, we're going to have a party, okay? Mole Day party. Okay, so 6.02 times 10 to the 23rd atoms or molecules is the number of particles in 1 mole, okay? A couple other things we need to do before we do a little bit of math here, okay? This idea of molar mass, okay? A molar mass is the mass of 1 mole. That's why we call it molar mass, because it's the mass of 1 mole, and these are its units, grams per mole. Okay, the molar mass of an element is the atomic weight for the element from the periodic table. Okay, so if you're looking at oxygen, 16.00, sulfur 32.07, okay, or 0.6, depends on the periodic table you're looking at. Okay, remember, if it's diatomic, you always have to double it. Okay, so the Hofbrinkels, remember those guys? Yeah, you got to double them. Okay. Now, if you're looking at a formula, so that's just for individual elements. If you're looking at a formula, you've got to take you take the mass of everything. So remember last video we talked about formula weights. And so you're going to use the formula weight and just change the units from AMU to grams per mole, and you're good to go. Okay. So here's some just random mole ratios. Okay. One, just to give you an idea of how this works, notice that the number is always equal to 6.02 times 10 to the 23rd. Okay, that's the common factor. Formula weights and molar masses are always exactly the same number. They just have different units. All right, and then and then these are the formulas here. Okay, so here's the big takeaways here. All right, 1 mole of atoms, ions, or molecules contains Avogadro's number of those particles. Okay, the number of atoms of an element in a mole is the subscript in a formula times Avogadro's number. Okay, so here is your roadmap, and we're going to use this guy, and we're going to build off of this as we go. Okay, so this idea of moles allows us to correlate mass and number of particles, or formula units. I like to call these FUs. Okay, FUs. It's pretty fun. Anyway, so we go from moles, and it allows us to go from grams to formula units, okay, or number of particles here. Okay, so moles provide a bridge. Okay, using these equalities, we can convert from mass to atoms, and so let's do one here. So so we want to figure out how many atoms there are in 3 grams. So we're starting over here in the grams, right? We got 3 grams, and we need to get to formula units, because each individual guy here is a formula unit of copper. So we really need to figure out how many atoms of copper, or how many formula units there are of copper in 3 grams. So in order to do that, we have to go to moles first, and we have to use the molar mass. Then once we have the number of moles, okay, and then from there we use Avogadro's number to get to the FUs. And really, we can just use dimensional analysis. We practiced quite a bit in Unit 1. So here we go. So 3 grams of copper, Okay, first step is I got to go to moles. So I'm going to make my parentheses. All right, I'm going to put grams in the bottom, moles in the top, because I want my grams to cancel. Right, I'm going 2 moles. All right. For every 1 mole, I have so many grams of copper. Well, it's just my molar mass. So it's 63.55 grams. All right, so that's half my battle. I'm in mole land now. Okay, so there's that. So now I'm going to put moles in the bottom, and I'm going to formula units, which are atoms. Okay, and so for every 1 mole, there's 6.02 times 10 to the 23rd atoms. All right, so I simply take 3 divided by 63.55 times 6.02 times 10 to the 23rd. And I get 2.841856806 times 10 to the 22nd. So anyway, so this has 1 sig fig, so it becomes 3 times 10 to the 22nd atoms. Okay, so that's that. Pretty easy. All right. So let's do a couple practice problems here. All right, so it says, how many sulfur atoms are in 0.45 moles of barium sulfate? So that's part A. All right, so we'll just do this one here. So we've got 0.45 moles of barium sulfate, and we want to get to how many atoms of sulfur there are. So first we got to figure out how many atoms, or how many formula units of barium sulfate I have. So I'm going to go to those first. Okay, so I'm going from mole to FUs. Okay, so for every 1 mole of barium sulfate I have 6.02 times 10 to the 23rd FUs. Okay, formula units. And then we're going to go from formula units to number of, we'll get rid of the number, I don't like that, so we'll use the number. We'll erase that. Oh my goodness. All right, to atoms of sulfur. Okay, so for every 1 barium sulfate formula, I have 1 atom of sulfur, so it's just a 1-to-1 ratio, right? And so I know that it's 1 sulfur because there's no subscript here, so it has to be 1. So I take 0.45 times 6.02 times 10 to the 23rd times 1, and I get 2.709 times 10 to the 23rd. Okay, and there's 2 sig figs here, so my answer needs 2, so it becomes 2.7 times 10 to the 23rd atoms of sulfur. All right, so that's that guy. I just want to pause and make sure that I'm recording. All right, I am recording. For a second, I thought I'd forgotten. All right, part B here. So we got 1.10 moles of aluminum sulfide. All right, so first step, we need to figure out what the heck aluminum sulfide is. Whoa, what the heck is aluminum sulfide? All right. So aluminum is Al, and it forms a 3+ ion. Okay, and then sulfide is just an S, and it forms a 2- ion. So we're going to crisscross. So we'll put it so it would be Al2S3. All right, so that's our formula. All right, we might need that in a second. It's worth the time to always figure out whether or not you're going to need it. Okay, so we have 1.10 moles of Al2S3, and we want to figure out how many sulfur atoms again. Okay, so first we got to convert it into formula units of aluminum sulfide. So we'll put moles down here, and then formula units up here, 1, and then 6.02 times 10 to the 23rd formula units. All right, so that's that. Now we're going from formula units of aluminum sulfide to atoms of sulfur. Okay. So for every 1 formula unit of aluminum sulfide, I have 3 sulfur atoms. So I'll put a 3 there. So we'll take 1.10 times 6.02 times 10 to the 23rd, and then times 3, and it becomes 1.9866 times 10 to the 24th. This has 3 sig figs. Okay, this is a counted value, so it has unlimited sig figs. So it becomes 1.99 times 10 to the 24th. 1.99 times 10 to the 24th atoms of sulfur. Okay, so that's that guy. All right, I think I got a couple more practice problems. Why aren't you going? Oh, here we go. Calculate the number of moles. That's the practice problem. I won't do that one because you can watch it on your own. Why is it struggling so much? Okay. All right, a 508 gram sample of sodium bicarbonate contains how many moles of sodium bicarb? All right, so now we're going from grams to moles. So in order to do this, we'll need to use the formula weight, but let's write it out first. So we got 508 grams of NaHCO3. All right, we got to go to moles. All right, so we'll draw this guy. So we're going from grams to moles, 1 mole, and now we got to figure out the molar mass. So we have 1 sodium, we have 1 hydrogen, and we have 1 carbon, and we have 3 hydrogens. Okay, so sodium is 22.99. Yep, 22.99, and then hydrogen is 1.01, carbon is 12.01, and all these are multiplied by 1 because I only have 1 of each, and then we've got one more. Why did I say oxygen? This is oxygen 3 times 16.00. Okay, we're going to add those guys up. All right, so we take 22.99 plus 1.01 plus 12.01 plus 3 times 16, get 84.01 grams per mole. Okay, so this is the number that's going to go down there, grams per mole, and that's it. So now we'll take 508 divided by our answer, and we get 6.05. This has 3 sig figs, so that's good. 6.05 moles of NaHCO3. Cool. NaH 22.99. I just want to make sure 12.01, 3 times 8. All right, cool. All right. All right. Converting moles to grams. So this is going backwards of what we just did. We'll only do one of these because I'm sure you guys are getting tired of watching me do this. Let's do this guy because we just did sodium bicarb. Sulfuric acid. Okay, sulfuric means you ate something icky, so that means it came from the sulfate. Sulfate has a charge of 2-, so that means we need 2 hydrogens to match it, H2SO4. All right, so we're starting with 3.0 times 10 to the minus 5th moles of H2SO4. We're going to put moles in the bottom. We're going to put grams in the top for every 1 mole. Now we got to figure out the molar mass of this guy here. So we have 2 hydrogens. We have 1 sulfur. We have 4 oxygens. All right. So 2 times 1.01 times 1 plus 1 times sulfur is 32.06 according to this periodic table. I'm pretty sure the ones at school say 32.07. But anyway, so 16.00. We add all those guys up, so we get 2 times 1.01 plus 32.06 plus 4 times 16. I get 98.08 grams per mole. All right, so we throw in the 98.08 up here. Okay, so we get 3 times 10 to the minus 5th times 98.08. We get 0.00294. 2 sig figs in scientific notation because we're cool kids. Right, 2.9 times 10 to the minus 3rd grams of H2SO4. So not very much, but it's all right. That's the answer. Cool. You can do those practice. All right. So now we're gonna. These are 2-step problems. Okay. It says how many chlorine atoms are in 12.2 grams of CCl4. So this is exciting. So this is gonna be like more than 2 steps. This is gonna be like 3 steps. Ooh. All right. So we're starting with grams. So that means we have to go from grams to moles. Then we have to go to formula units. Then we can go to number of chlorine. All right. So that's our steps here. We got 3 steps. So we're going to start with our 12.2 grams of CCl4. All right. All right. Grams go on the bottom. Moles go on the top. Okay. So we got to figure out the molar mass. All right. So 1 mole. So here we go. So we've got 1 carbon and 4 chlorines. Okay. Add those guys up. So carbon is 12.01. Chlorine is 35.45, but we got 4 of them, so 35.45. All right, so we 12.01 plus 4 times 35.45. We get 153.81. 3.81. So that's the molar mass of carbon tetrachloride. 153.81. All right, so now we're in moles, but now we get to go to formula units. So mole to formula units. So that ratio is Avogadro's number, 6.02 times 10 to the 23rd. All right, and then from there, we got to go to the number of chlorine atoms. Well, for every one of our formula units, we have 4 chlorines. All right, so we take 12.2 divided by our molar mass times Avogadro's number, times 10 to the 23rd, and then times 4. So we get, there's 3 sig figs, so it would be 1.91 is what I got. 1.91 times 10 to the 23rd atoms of chlorine. Right? 1.91 times 10 to the 23rd atoms of chlorine. Yep. And that's it for this video. We talked about how to convert moles to grams, grams to moles, and then go all 3 different directions with all that stuff. Anyway, do your homework. Let me know if you have any practice problems. This stuff's very, very, very important to understand how to do. You need to be able to do this flawlessly. Otherwise, the rest of the chapter and then the rest of the semester and the rest of the next semester is going to be a pain in the neck. All right, so make sure you put the time in to understand how to do this. If you don't do that, it's going to be very difficult. All right, come see me for help.